All right, let's continue our class from last week. So last week we talked about the block shear fracture. Then we talked about the tension member connect to a cassette plate. You might have a block shear failure with the shear surfaces in AB, and the BC is tension fail surface. If you have a plate, tension plate connect to a cassette plate, you might fail block shear in cassette plate as well as block shear failure in tension member. So if you encounter these cases with a plate connect to a cassette plate, you need to check both cases, the block shear in cassette plate as well as block shear in tension member. And you need to discuss which one govern the block shear rupture for this whole connections, including cassette plate and the tension member. So please be careful about this. Okay, you got to check both block shear in cassette plate and block shear in tension member. Okay, because cassette plate may be weaker in block shear. Okay, so you got to check. So last week we talked about the equation. It's a combination of shear and the tension strength. So these two combined, we call R sub n is the nominal block shear strength, 0.6 Fu times ANV, and plus Fu times ANT. ANV is the net area along shear surfaces. ANT is the net area along tension surfaces. Okay, so like we mentioned last week, if your tension stress is non-uniform, the equation add a correction factor 0.5 in second term if your tension stress is non-uniform. If your tension stress is uniform, then this term become 1. Okay? And also, the AIC specification limits this term to 0.6 Fy HEV. So what is HEV? Is a gross area along the shear surfaces. 0.6 Fy is the shear yielding stress. We taken as 60% of tensile yield stress. So with all that being combined, we arrive at this equation J4-5 in specification. So your block shear is 0.6 Fu ANV plus UBS FUNT. But this equation need to be less or equal to 0.6 Fy HEV plus UBS FUNT. Again, the UBS term here, like we discussed, when tension stress is uniform, in most of the cases, UBS is 1. When some cases, tension stress is non-uniform, UBS is 0.5. Typically, non-uniform cases, it's rare. You need to go to commentary to see what will be the cases apply for tensile stresses is non-uniform. But most of all is the uniform tensile stresses. For block shear, based on LRFD, the resistance factor is 0.75. V is 0.75. For ASD, the safety factor omega is 2.0 for block shear rupture calculation. Like I mentioned last week, this equation J4-5 is for bolted connections. But block shear can also occur in welded connections, especially in the cassette plate. So if you're welding connection, you can still apply for this equation, but you don't have net. Everything's gross. So that's the only differences. Because welding connection, you don't have any bolt, no net connection to talk about. Okay, and also the limit states combine ART and SD in one slide. Here I show you the equations. So PU is the demand based on factor load combination. V is 0.75 in nominal strength for block shear, we just talked about. As for SD, PA is a service load combination should be less or equal to nominal block shear strength divided by safety factor, which is 2.0. So this is what we end up with last week. Any questions so far regarding block shear?
Can you go to the first slide of today's lecture, Professor?
First slide?
Yeah.
This one?
All right. Got it. Thank you, sir.
Okay. Any other questions? Okay, yes, now let's move on to example 3.10 to compute the block shear strength of the tension member for this angle. L is an angle 3/2 by 3.5 by 3/8. It's A36 steel, and the bolt is 7/8 inch diameter bolts. Use ART as well as use SD. So if this is a tension member, the block shear will happen like this. So this piece will be torn out if you have a tension force like this. So this is the area we need to focus on to calculate our block shear. So the shear area, the gross, will be the distance from center of this bolt to the edge of the member, which is 3 plus 3 plus 1.5. So that's why 7.5. And thickness of this angle is 3/8. So that's why your gross shear area is 2.813 inch square. As for the net shear area, it will be 3 plus 3 plus 1.5 is 7.5. But how many bolts you have? You need to subtract along the shear area, which is 1, 2.5. So 2.5 of the effective bolt diameter you need to subtract, and times the thickness of the angle, you got 1.875 inch square. Any questions so far regarding the gross and the net shear area?
Can you please do the gross again, please?
The what? The gross?
The gross area, yes.
Which part?
Yeah, the AGV gross area of shear.
Okay, so you're talking about this area is in here. So 3 plus 3 plus 1.5, and times the thickness of the angle. So that's the gross shear area for this angle.
Professor, can you explain the minus 2.5 and then times 7/8 plus 1/8?
Sure, because the total length is 3 plus 3 plus 1.5, so this is no questions. But to find the net, you need to subtract the distance occupied by the bolt diameter. So how many bolt diameter you have along the shear area?
2.5.
Yeah, 2.5. You got 1 bolt, 2 bolt, and half bolt here. So 2.5 times effective pole diameter. So it's from here to the center. Now I hope I can have here to the center of the last bolt. So that's why it's half. So 2.5. Okay?
Okay, thank you.
Mm-hmm. Any other questions?
No, sir.
Okay, great. Now, for net tension area, same thing apply. The distance from here to here to center of the bolts is 1.5 because total from here to here is 3.5. So -2 is 1.5. But you need to subtract half of the bolt diameter to get a net tension. So it's 1.5 minus half bolt diameter, effective hole diameter, times 3/8 thickness of the angle. You got 0.375 inch square. Any questions so far for net tension? Any questions?
No, sir.
Okay. So because here we assume the tension stresses is uniform, so UBS is equal to 1. Like I said, in most of the cases, it will be 1.0. So you apply for equation J4-5, because this is A36 steel, so Fu is 58 KSI. So you plug into this equation, you got 87 kips. But remember, you got upper limits, which is 0.6 Fy HEV plus UBS FUNT. So your Fy is 36. HEV, you just calculated, ANT is here. So you got 82.51 kips. So meaning 87 violates the upper limits. So the only value you can take is the upper limits, which is 82.51 kips. Okay? So this is the nominal. So for ARV, your design strength will be phi 0.75 times 82.51 is 61.9 kips. So this is the capacity for block shear rupture per ART. For allowable capacity, allowable strength based on AST will be nominal strength divided by omega, which is 2, is 41.3 kips. So this will be the allowable strength based on AST for block shear rupture. Okay? Any questions regarding this example?
Professor?
Yes.
I have a question in general, and I think you've answered it before, but in for the ASD method, it's okay for us to, is it okay for us to always use the strength instead of the stress?
Yes,
Okay.
I think I answered that before.
Yeah.
I think most of you prefer to use allowable strength, right?
Yes.
That would be more straightforward, like what I'm talking about here, right?
Yes, exactly.
Yeah. The way that I cover stress and strength is to give you option.
Yeah.
I'm not forcing you to use either one. As long as you feel comfortable use strength, I'm fine with that.
Perfect. Thank you, Professor.
Okay. Good question, Jocelyn. Any other questions?
So the U is equal to 1 because it's going on the normal side of the angle.
Not only that, because it's uniform. Because when I say uniform, meaning the stresses on these surfaces is uniform.
Don't even think you're gonna go to sleep.
That's what it means. Because in some situation, the stresses might vary like this. It may not be uniform. You know what I'm talking about?
Kinda. So that would be if they're staggered.
Not necessary. It depends on the situation. So like I said, you need to go to the commentary,
Is that okay?
like I mentioned here, on chapter J, for discussion about UPS. Some situation, the tensile stresses on the tensile area may not be uniform. Okay?
Why would it be okay,
Okay.
for you to go to sleep till 3-4?
Like I said, most of the cases for angle, cassette plate, in most of the cold beams, the tensile stresses for plug shear is uniform. So that's why you can use U is equal to 1. Any other questions?
Is there ever a chance where those bolts will be spaced out like differently, so then they wouldn't necessarily?
Yeah, it's possible. Why not? It's possible. It may be you are talking about something here, right? Space out. Maybe let's say this is 4, right?
Yeah. So that would that be non-uniform then?
It'll still be uniform.
It'd still be uniform. Okay.
Yeah. It's nothing to do with this. It's for other situation, which I'm not going to cover here. If you have a both cases like this, you're just extending your shear area and tension area like this. Still plug shear, okay?
Okay.
Well, Professor, if that's the case, then only the shear area will be affected, right? And the tension area will be the same. If you assume
Yeah, the same. Yes, you're correct. You are extending the shear area. That's correct. Any other questions? Discussions?
Can you do the tension area again?
Which one?
The tension area?
Uh-huh. So which part?
Not for the shear, but
The tension?
yeah, tension.
You mean the calculation?
Not the calculation, just where like draw it on the beam, if you could, or the member.
You're talking about the one I just drew like this?
Yes, perfect. Thank you.
Yeah. So here, this is the same like this one. Here, did you see this? This is what I mean uniform. Because all the stresses is constant. Okay?
Okay.
When this is not constant, meaning it's not uniform. So then UPS is equal to 0.5. Okay? Any other questions? No?
No, sir.
All right. Questions?
No, sir.
Okay. Now let's move on to section 3.9. We call design of tension member. Okay? So far what we did is do analysis of tension member. So I give you the size, I give you the material, you do the calculation to figure out the capacity, etc. That we call analysis. Now, design is different. Design is I give you the loads, and then I give you the material, and you pick the sections to resist the loads. So this is what we call design. So design of the tension member involves finding a member with adequate growth and net area. If the member has a body connections, then the selection of suitable cross-sectional area require accounting for area lost because of the hole. For member with the rectangular cross sections, the calculation are very easy and straightforward. But if you use W sections, for example, the area to be deducted cannot be predicted in advance because material thickness at the location of the hole is not known. So you got to do a lot of trial and error iteration process until you pick the sections to resist the loads. Okay? A secondary consideration in design of tension member will be slenderness. So if a structural member has a small cross-sectional area relative to the length, and we call slenderness ratio, which is L over R. L is the member length. R is the minimum radius of gyration of cross-sectional area. So I think I mentioned this before. The radius of gyration, you need to pick the minimum, is equal to square root of minimum moment of inertia divided by cross-sectional area. So L over R we call slenderness ratio. So in tension member, there's a limit for slenderness ratio. So this R minimum, you can check out this value from part 1 of the manual, okay? For different shapes. Any shape in the part 1 of the manual, you can figure out a number for minimum radius of gyration. And from there, you can plug into L over R to get the slenderness ratio of this tension member, okay? Remember, in the exams, if there's a design problems, I will give you the dimension of the cross sections. And what you need to do is to calculate and pick the thickness in the exams. So that's why everybody can be consistent for the answer. Otherwise, you can come up with several different answers because everybody's design has different option. Maybe I would like to pick 5 by 8. Another guy want to pick 10 by 8. But I will fix the dimension. For example, the cross-sectional dimension. And what you need to do is to do the calculation and select the thickness based on your calculation. So this way everybody can come up with the same solution in the exams. Okay? So this is what I'm going to do in the future exams as well. Any questions so far regarding design of tension member for these slides?
No, sir.
Okay. So with that being said, the central problem of all the member design, including tension member design, is to find cross sections which the required strength doesn't exceed the available strength, meaning the capacity demand cannot be bigger than the capacity. So for tension member, based on LRFD, the requirements is PU, the demand should be less or equal to VT times PN. So the right hand side here is capacity. The left hand side is demand. PU is summation of the factor load based on the load combination. So to prevent yielding, 0.9 FYAG should be bigger or equal to PU. In other words, for design problems, your AG that you are going to pick should be bigger or equal to PU divided by 0.9 FY. To avoid fractures, likewise, your effective area should be bigger or equal to PU divided by 0.75 FU. So these are the two different criteria. One, prevent yielding. Another one, avoid fractures. Any questions so far?
No, sir.
Okay, so I think very, very straightforward for the equations. Now, for ASD, some of you, like you just mentioned, if you use a level stress, the requirement corresponding to yielding will be Ag should be bigger or equal to P allowable divided by 0.6 Fy. So like I said, PA here is a low demand based on ASD low combination. Divided by 0.6 Fy should be less or equal to Ag. Likewise, if you guys want, you can use the allowable strength equation. Okay, you will reach the same result. For limit state of fractures, effective area required should be bigger or equal to PA divided by 0.5 Fu. So this is based on allowable stress form. So likewise, if you guys prefer to use allowable strength, you can modify this term, and then you can reach the same equations. So I'm not going to repeat in here. So this is ASD design equation for tension member. Any questions so far for these slides?
No, sir.
Okay. Now, for slenderness ratio, there's a limitation you need to satisfy. Your minimum radius of gyration should be bigger or equal to L over 300. So this is a requirement. The section you pick need to have minimum radius of gyration bigger or equal to L over 300. And L is the length of the tension member. Okay? Any questions?
Professor, can you go back to the last slide real quick?
This one?
Yeah, I was still writing something down.
Okay. Go ahead.
Okay, I'm good. Thank you.
Sure. Any question for these slides?
Can you go back to the one with a fracture as well?
This one?
One before that.
This one?
Yes, thank you.
Sure.
Okay, I'm good.
Sure. So now with that being said, let's move on to one of the example for the design. Example 3.12. So the problem wants you to select an unequal leg angle tension member is 15 feet long to resist a service dead load 35 kips and service live load 70 kips. Use A36 steel. So the connection is showing in here. And the bottom plate is the cassette plate, and the tension member is in here. And as you can see that you got 2 rows of bolts. Each row has 4 3/4 inch diameter bolts. So you need to design an unequal leg angle for this to resist the service load 35 kips dead and 70 kips live. So this is the problem statement. So how do you do that? So based on LRT, the effective load is based on load combination. Your PU is 1.2 dead plus 1.6 live. You got 154 kips. So based on yielding, you require AG is PU divided by VFY. So you got 4.75 inch square. As for fracture, the required effective area is PU divided by V times FU. So it's 0.75 times 58. So based on yielding, your gross area minimum is 4.75 inch square. Your effective area minimum is 3.54 inch square. So this is the two area you can pick the selection, the criteria to pick your cross-section area. The minimum radius of gyration should be at least L over 300. Remember the L is in feet. You need to convert to inches. Divide by 300 is 0.6 inches. When you talk about design, we always need to pick the lightest shape. We want to be most cost effective as possible. So usually we start with the lightest shape to satisfy the criteria above. So you need to go through the part 1 of the manual to look for the smallest acceptable gross area, as well as check the effective net area. So what you need to do is to pick the smallest acceptable gross area, which is as long as you can satisfy this one, and you will check based on the bolt layout if you can satisfy the minimum effective area is 3.54 inch square. So that will be the procedure that you can do. Like I mentioned before, in order to fit 2 lines of bolts in one leg in the angle, you need to have a minimum 5 inch long for the leg. So with that being said, we can try 6x4 by half, because 6x4 by half have area 4.75 inch square, which is exactly the same like this number. You can pick any section bigger than 4.75 inch square, but we need to pick the minimum for that one. And also now, I want you guys to go to your manual, part 1, go to L 6x4 by half. I want you to read this number carefully. Minimum radius of gyration, 0.864. Can you go to part 1 of the manual? So I would like to explain to you about this one. So if you guys already found it, part 1, go to angle 6x4 and half and tell me what you got. I need to explain to you further. But please go to that page before I explain to you. If you got there, put on the chat, or you can just directly answer and let me know.
$1.91.
1.91. Which edition you have?
I
The
think
15th.
15. Okay.
I got 0.864 for the Axis ZZ.
Okay. So 6x4 by half. If you are 13 edition, you can go to 1-42. Okay, you will see in 1-43. So if you go to 1-42 and 1-43, remember when you read that table, it's covered both pages. It's not only one pages, okay, for one sections. As you can see, if you read the manual carefully, you will see the axis X-X, as well as axis y dash y, as well as axis z dash z. Okay? So, do you guys see that?
Yes.
Yes, sir.
You have axis xx, axis yy, axis zz for 6 by 4 by half. Did you guys see that?
Mm-hmm.
Yes.
Okay, so this value is coming from r zz, which is about the axis zz. Just remember that. The reason is that because this angle is unequal leg. And if you see the cross-sectional dimension definition, they call this is x, and they call this is y. Okay? But because this is unequal, based on the strength of material, ME 373 that you guys learned, the xy axis here is not minimum. The actual minimum is the z-axis, which is somewhere here. The table already figured out for you. So you got to use RZZ, not RXX or RYY. So this is for unequal leg. You have RZZ. If your section is symmetric, then you don't have RZZ. You have RX, X, and RYY only. Just remember that. Okay? Any questions?
So it's whichever one is the minimum of the three?
You can say so, but to be more accurately defined, it should be RZZ.
Well, yeah, because he's saying if it's unequal, then we use the X or Y, right? And then
If that's symmetric, use either RXX or RYY, the minimum.
So yeah, you wouldn't use RZZ, which would be smaller than those. Yeah. So I think it's only if it's unequal that we use essentially the minimum value.
Yes. If it's unequal, use RZZ, which is minimum out of the three. Right?
Yes.
Mm-hmm. So with that being said, this is bigger than 0.6. So this is fine. So we can start to calculate a net area, which is AG minus the area of the hole. And as you can tell, for fracture, we got 2 holes. So you have 2 subtract 3/4 plus 1/8, and die thickness, you got 3 875 inch square. Because the length of the connection is not given yet, so equation 3.1 cannot be used to compute the shear leg effect, U. So here we're gonna use alternative value because you got 4 bolts per row, so you can use U is equal to 0.8 instead. So with that being calc, you less than 3.54 by requirement. So this is no good. So you need to keep trying for another sections. And then finally, we try 8/4 by half. And then we repeat the same process. And we check our effective area is 3.9 inch square, which is bigger than 3.54 inch square. So we call it okay. So the shape satisfy all the requirements should be L 8/4 by half. So this is trial error process, take a lot of iteration. But like I said, in the exams, I will fix this 2 number for you, and you need to go through the process and to justify the thickness during the exams. Okay? Any questions?
Can you go over the previous slide, the slide again? A little bit slower, maybe.
This one?
Yes.
Okay.
Professor, I had a question. So, going back to the manual, when we were choosing R, you said we're doing the axis Z sub or Z dash Z. So, are we choosing the minimum of the R versus the Y sub or Y dash Y, or how are we choosing that?
You are looking for the R about the axis ZZ, not about axis XX and YY. There are 3 R if you look at the manual, one under XX, one under YY, and there's another one under ZZ. You need to pick the one under ZZ axis.
Okay, so we're always choosing the one under Z. ZZ.
That's for unsymmetric section.
Okay, for symmetric.
Mhm.
Okay. Will we be giving any problems where they're not symmetric in this class?
This example already unsymmetric.
Right, but will we be given any like problems where they're non-symmetrical? Or
I cannot tell you. I can give you symmetric or unsymmetric. It depends. It can be anything. As long as you remember, you need to pick the minimum radius of gyration. I think that will be fine.
Oh, okay, so if we just pick the minimum out of,
Mm-hmm.
then we should be good.
Mm-hmm.
All right, thank you.
Mm-hmm.
But if it is symmetric, we're not going to pick RZZ.
There's no RZZ for symmetric, only X and Y.
And then we
Sounds good.
pick the minimum from those two, correct?
Yes, yes.
Well, I think XX and YY will be the same if it's symmetric, right?
It depends on what kind of symmetry we are talking about. If you X and Y both symmetric, the dimension is the same, then yes, they are the same. But typically, it will not be the case in steel design. Okay?
Okay.
My manual still has a ZZ section for symmetric ones, so just ignore that ZZ completely.
We don't need that value because that one is not minimum at all. If the section is symmetric. So that's why if you check the table, there's no RZZ for symmetric sections. Double symmetric I'm talking about. Okay?
You see? Open your mouth. Open your mouth. Mia. Sister.
Because the table already gave you XX and YY. One of them is max, one of them is minimum.
Not like you.
Already. You don't need to do
¿Ya te lavaste
ZZ.
la boca?
I need to go do that right now.
Didn't I tell you like 3 hours ago?
Well, Professor,
Mm-hmm.
for example, I take a look at the shape L12,
Open your
12.
mouth.
You're the
One,
worst kid on
38.
earth.
So
Thank
that's
God I'm not your
symmetric.
parent. I would have whooped your
Which
ass
one?
like my mom.
Open your
For,
mouth.
just pick one. You know, on this
I wanna brush your
L12,
teeth.
12,
I
138.
wanna brush your teeth. I wanna
Yo.
brush your teeth. Sister, look, I'm brushing your teeth.
Can you type in the chat? Let me see which one you are talking about.
Sister! Look!
So this is the angle you are talking about? I did not see 12 by 12. I only have 8 by 8 for angle. You sure you got 12 by 12?
They have a 15 edition. They got the 12 by 12 by 138.
Yeah, there's a Z dash Z for that here. I found the minimum R to be 2.30.
For angle, it doesn't matter. As long as his angle is unsymmetric. You always have XX, YY, and ZZ.
What the hell happened to this ball?
It's
Yeah,
not symmetric section at all.
Oh, I
always
see
have
what you're
ZZ.
saying. I see what you're saying. No matter even if both sides are like an L6 by 6, even if your two lengths are the same.
Doesn't matter as long as it's non-symmetric.
So for an angle, okay, yeah, I was getting a little confused there. For an angle, you're always going to use the RR value because it's always going to be unsymmetric. But if
It's
you have,
ZZ axis.
if you have like a square, if you have like an HSS, which is a square, that would be symmetric, right? You would just
It's not like a square. For example, doubly symmetric. That's what I'm talking about. For W shape, for example, It's a doubly symmetric. You only have XX and YY. There's no ZZ. But for angle, it's non-symmetric section. You always have XX, YY, and ZZ.
I see. Yeah, I see.
Pick the
So,
minimum.
so for an angle, you would always use that ZZ value.
Yes. Okay.
Got it. Thank you, sir.
Uh-huh. So for SD, we can follow the same procedure, but now your law combination is dead law and live law only, no factor. So it's 105. So following the same equation, your required gross area is 4.86. Required effective area is 3.62. Required radius gyration minimum 0.6. So you follow the same procedures. You pick up the same section, which is 8 by 4 by half. So this is what we end up with, the same solution. It just coincidentally, this example give you the same result from both ASD and RFD. But like I said, most likely, typically, different design method will give you different result. Okay? Any questions?
Yes, sir. So in reality, when we have two different results, is it gonna be?
What's the question?
So in reality, let's just say that we use both method and then we got two different results. And
Yeah.
we got two different section, right? And it's gonna be who's gonna decide which to use.
Depends. You are the structure designer. You decide which method you want to use. There's nothing wrong as long as you follow the procedure. You pick different section. That's fine. As long as it works, it's not fail, then you are doing a good job. So there's no standard solution for that
Got
when we
it.
talk about design.
Thank you.
Mm-hmm.
Stop licking your VV. Nasty.
Professor, you said for the exam we're going to be choosing the thickness. So, like, you would still give us the first part, correct? Like, if it was like an L8 by 4.
Yeah, I will give you the first two dimensions and you pick the last.
Okay, and then okay, so that's the
Uh-huh.
Okay.
But in homework, I give you the freedom to try.
right. We just go through the same process of
And do iteration until you satisfy everything. So in homework, as long as you make the effort, you try, I'm fine with that. But you need to pick the lightest. If the problem wants you to pick the lightest, you need to follow the problem statement. Which one is the lightest? Okay? Which is the smallest gross area. Otherwise, you can pick whatever you want.
Seahorse.
Okay, so like find the smallest gross area though.
Uh-huh.
You like choosing the smallest thickness then?
The same thing.
Yeah. Okay. Thank you.
Mm-hmm. All right. Any questions or discussions?
Mm.
No, sir.
Okay, and then,
What?
so with that being said, I need to talk about, there's one explanation I need to explain to you for your homework number 2, problem 5.
Okay. Good job.
So I think last week there's a student asked me,
Good job.
there's no boats in here, but instead there's a
Okay.
boats in here.
Okay. Call me back.
Oh, sorry. So let me
Goodbye.
go back here.
Huh?
So this will match.
Yeah. Coming back. Bye.
In here.
Pendeja.
Okay? So there's no bolts on top because the plate is right in here. Cassette plate in the middle for the connections. Okay? This is problem number 5 and homework number 2.
Sounds good.
Okay, any questions? So this is one of the explanation I would like to mention to you. All right, so with that being said, so we finish chapter 3, finally, with a very long journey, and with all the explanation, example, the lecture, we finished chapter 3. So now with that being said, I have a few announcements I would like to announce. Number 1,
Test.
so the homework number 2, due day, will be on Monday next week, which is March
Test
22.
on Wednesday.
By 5 p.m. So the Dropbox folder for homework number 2 already created. So you are welcome to just submit to the Dropbox. So like I said, when you submit, as I already mentioned on homework number 2 problem statement, your file name is follow this format. Okay? Nothing else. Make it straightforward and easy. Homework number 2 solution will be posted on the same day after 10 p.m. So you guys will have time to look at the
Test Wednesday.
the solution. Okay? So that will be homework number 2. And regarding your midterm, number 1, I plan to have that after spring break, which is April the 7th.
Thank God.
I plan to give you guys more time to study and prepare for your midterm number 1, because this is the first exams. I would like to give you guys more time to study and prepare. How about that?
Thank you.
Thank you.
Thank you so much.
Is that good for everybody?
That's perfect.
Yes, thank you.
Uh-huh.
Yeah, it works for me. Yeah, thanks.
Okay, so the time will be 3:30 to 4:45 p.m. And the topic, chapter 1, all the way to chapter 3,
Where's the baby? Where's Mia?
including homework
Where's
number 1 and 2.
Mia?
You can
Where's Mia?
practice, and with that. And this is a closed book
Where's Mia?
exams.
Where's Mia? Where's
You're only allowed to use 1 page,
Mia?
letter size,
She's like, I'm your bitch.
cheat sheet, back and front and back.
Where's Mia?
I'm back.
She's lost.
And you only allow
Go back and
equations, not simple calculation. You need to submit your cheat sheet together with your answer sheet as well. So I will check what did you write down on your cheat sheet. Do not violate the rule. And you're also allowed to use manual during the exams. So that will be the overall procedure that I would like to mention to you. And also next week, I think a lot of students need to take the EIT exam as well. So that's why I try to avoid next week. And also I can give you guys more time to prepare your midterm 1. Like I said, this is the first time that you guys learn steel design. I can understand some of that still get used to it. Okay, so April 7th will be more reasonable for everybody to prepare. I want you guys to do a good job for your midterm 1. And for our midterm 2, I was scheduled on the end of last week of April, which is April 28th. So now it's tentative. So midterm 2 will be based on chapter 4 only. So that will be midterm 2 at the end of April. So that will be the plan. And your homework number 3, which is based on chapter 4, is coming soon as well. So this Wednesday, we are going to cover chapter 4, which is column. Analysis and design of column. And homework number 3 will coming soon as well. So that will be the overall plan I would like to announce. Any questions or discussion about the plan?
Did you say we're going to need to submit our cheat sheet?
Yes.
Okay.
So you can use any paper to write down your answer sheet, and then when you scan together with your cheat sheet for me to see.
I see. Okay.
So just to clarify, it's an 8.5 by 11.
You mean the cheat sheet?
Yeah.
Cheat sheet letter size, yeah. Cheat sheet, typical letter size. And no type set on your answer sheet is allowed. You need to write down, not by computer typing. I want you to use handwriting. If I see any computer typing, I'm not going to give you any credit. Only handwriting, okay?
Can we write on an iPad, Professor?
No, everything by handwriting on the paper. Just treat it as if you are in person on campus taking the exam. That's it. No computer. Nothing else. Just handwriting on the paper. So let me put a notes.
But you said, I believe at the very beginning, the very first class we had, that for the solutions for the construction manual, that we can use a PDF of that for the test, right?
Oh, that's okay. That's fine. That's totally fine. So the manual, you can use hard copy or PDF. That's fine. That's the only thing you can look at it. Other than that, you cannot. And also, only handwriting on answer sheet is allowed. Otherwise, no credit will be given. I will email guys the detailed exam policy and regulation later on. And I'll also post the policy on the Pitchboard as well. But now I just give you a heads up to see what's coming up. You can start to prepare. So that will be the plan for homework 2, due day and solution, and also midterm 1. And this Wednesday, we are going to cover chapter 4. And midterm 2, still at the end of April. And midterm 2 is based on chapter 4 only, and also homework number 3. Okay? We have 2 midterm we need to do. But we postpone midterm 1, but let's give you more time to prepare. So that will be the overall plan. Any other questions or concern?
Professor, how many questions could we expect? Do you know?
So far, I don't know yet.
Okay.
But you need to practice yourself about the manual, example problem, and homework.
Professor, is the exam going to have any conceptual problems, or is it just going to be all problem solving?
It depends. I haven't have anything on my mind yet. It can be anything. You need to study everything that I cover.
Study the
You
whole book.
sound like you're my best friend.
Okay,
Why?
but we're not allowed to write any conceptual stuff down. Just
No, just equation. So I don't want you to memorize the equation. But other than that, you need to understand everything.
right, but we could still define the equation, say what you.
Yeah, that's fine. If you have anything defining the equation, that's fine.
No?
Okay.
Or is that screen recorded?
Any other questions? No?
Yes, sir.
Okay, so I think that will be the overall information I would like to convey to you. All right, so I think today we have a very long lecture as usual, I give you a lot of information already. So I'll stay here online for a few more minutes to answer any question you guys have. If not, we'll see you guys on Wednesday, and we'll start on chapter 4, which is column. Okay?
Thank you, Fred.
Bye-bye.